Hey everybody, this is Barnaby. Timmy's here too, trying to eat some avocado. We're reviewing some problems with you. So in 60B, if you need that one, if you need 61, that's the other one in this video, you can skip ahead. Steps are moles, mole ratio, answer. So to find moles, you do the volume times the molarity. Then to use the mole ratio, you need your balanced equation. So you write the HCl and the BaOH2, then the H from the acid and the OHs from the base react to make water. Leftovers are the Ba and the Cl. Barium's 2+ because it's in group 2. Chlorine's -1 because it's in group 17. So you need 2 of those to balance out the positive 2 charge. Then when you balance the equation, we need to react with the 2 OHs, 2 H's, so you put a 2 right there, and 2 OHs and 2 H's react to make 2 waters, so you put a 2 right there. So then you can use your mole ratio, take your moles that we already found, mole ratio of 1/2, you get your moles of barium hydroxide. Then the answer asks for volume, so we're going to use the molarity equation. Molarity is moles of solute over liters of solution. We can rearrange by multiplying both sides by liters of solution and then dividing both sides by the molarity. So you get liters as moles of solute over molarity. That's a worthwhile thing to practice doing if that kind of algebra is hard for you. And then a good thing also to do is check and make sure units cancel out. So moles cancel out, leaving you with liters on the bottom, which is the same as the top. So your answer is 0.0500 liters of barium hydroxide. That's a fine answer. If you want to convert it to milliliters, you get 50.0 milliliters. And then I'll move on to question 61. So first step is moles, then mole ratio, then answer. I'm trying to use the same steps for each problem in this chapter where you're finding moles first. So there's 2 numbers, 2 chemicals given to us in the problem. So you do liters times molarity to get moles of HCl. You do liters times molarity again to get moles of barium hydroxide. One of those will be the limiting reactant. For a mole ratio, we need a balanced chemical equation. It's the same as in problem 60 that we just reviewed. This one. And so I'm going to find the limiting reactant by converting to reactions. So these numbers come from the coefficients of the balanced chemical equation. And I find out that HCl can do a smaller number of reactions, so it's the limiting reactant, so it's all gone, which means some barium hydroxide is left, which means the whole solution is going to be basic, because barium hydroxide is a hydroxide, so it's a base. So then the problem says how much hydroxide is left, so I'm going to take my limiting reactant. Always start with the limiting reactant in these problems, and you'll get the smaller correct answer. Use my mole ratio to convert to barium hydroxide because that has hydroxide in it. That's how much is used. To find how much is left, subtract from the starting amount. Find out 0.0030 moles of barium hydroxide is left. The problem actually asks you for hydroxide, so we need to use 1 more mole ratio to find the answer and get hydroxide left. So you can just look at the formula. In a BaOH2, there's 2 hydroxides. So the final answer is 0.0060 moles of hydroxide left. Hope that helped.